There, let's try that again now. Can you hear me? Okay. So we are recording this session. So for those of you that have seen me before, I've been here, I think pretty much every time. So I'm Greg Kleinheinz. I'm from the University of Wisconsin-Oshkosh Environmental Research and Innovation Center, along with my colleague, Jackie Behrens, who's the Associate Lab Director there. And so we'll give you an overview of the sampling results for this. There is some new information. So as I was mentioning to a couple of people when they came in, I realize a lot of this is the same every time. So a lot of the background information, but we want to make sure if there's new people that they get that same information. And then we have tried to update and add, obviously more than there's a little bit more today than just the fall information. But really the goal of this session is just information exchange. So whether it's about this or something else, please feel free to ask. And I'll probably repeat your question just for the people online so they can hear what your question is, because sometimes it's hard for them to hear it. So, and I think we'll get done in an hour, just slightly under that. And anybody have any questions before we start? No? Don't ask me to change anything on the technology because we got it working, so we're going to go with that. So what the program goals, as we've talked about before, is continued education in Door County water resources, provide an avenue for residents to get the most accurate information, provide reliable information and guide county resources for the protection and maintenance of drinking water in the county, and be proactive with respect to drinking water. So instead of waiting for some situation to arise or always having to give the answer, I don't know, because people haven't looked at something. I think the county's been very forward thinking in terms of trying to create this groundwater database to understand what the conditions are below our feet. And hopefully we can establish some trends and data over time. And if people ask what's normal, at least there'll be some information now to be able to answer that question. So this is obviously a map of the county. Each of the yellow squares or sections are sections that have had well samples collected in previous years. The lined out, the sort of red lines are sections that have had people in the spring. So we see some of the same sections, and every year we end up adding a couple more. We haven't quite got the whole county covered, but quite a bit. And so we hopefully want to get the data spatially distributed with respect to soil type, depth of bedrock, land use, and all of that. So we'd ideally love to see the whole county covered, but we don't quite have that. I mean, as you all know, there's certain areas of the county that are more populated than others, and so it's easier to get samples. But to date, we've collected, as part of this program, almost 2,100 bacteria samples, just slightly less than that, a little over 2,000 nitrate samples, and about almost 1,600 arsenic samples. So we're now getting a pretty good size database in terms of the number of samples that are collected. And then, why is groundwater important? Obviously in Door County, I think, drinking water and wastewater is never important until there's a problem, right? As long as we turn our faucet on and our toilet disappears when we flush it, nobody really thinks too much about it. I mean, unless you're a little kid and have separation anxiety. it really isn't a problem. It isn't a problem for most people. But here we're challenged, right? So we have a karst geological situation below our feet, but that's not unique to Door County. So if you look at karst features around the United States, and if you're just dealing with Wisconsin, I think a lot of people are familiar with the driftless area in the southwest part of the state, or if you go down to Tennessee or Kentucky and some of the caves or Missouri. There's a lot of karst features around the United States, so this certainly is not anything that only affects Door County. But if we zoom into an image of the state and we look at the depth here to bedrock below the surface, 0 to 50 feet, that's red. So that's most of the southwest part of the state. And then once you get just out of Southern Door, it's pretty much all of Sturgeon Bay North, and even most of Southern Door as well. So very close to bedrock. And when we look at susceptibility to groundwater contamination, this table represents what's typical. So, least susceptible, green is good, red is bad. And so it really depends on, depth to bedrock, soil type, and depth to the water table. Generally speaking, in most parts of Wisconsin, in most situations, the greater depth you have to bedrock, you have soil that provides good infiltration capability. Those are things that make your water less susceptible. So, for example, in the center of the state, we see very highly susceptible groundwater, but that really doesn't have to do with depth of bedrock so much. It has to do with the infiltration rate of the sand, right? That's the central sands, and water filters through that very quickly and doesn't remove many of the contaminants, say maybe from agriculture or other things. The Door Peninsula has a different situation. You walk out the door and you put a rod in the ground and it probably goes thunk, 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 depending on where you are. But, bedrock is very close to the surface. I think this really tells the story because if you live on the western side of the peninsula, you're up on the escarpment, the depth to bedrock is not, too close, right? So, or the depth to water. You have a pretty good separation here. So from that standpoint, you would think that you'd have good separation from the surface down to your groundwater resources. However, if you look, and then on the eastern side, as it comes down to the lake level, we see it pretty close. On the left-hand side, it shows the susceptibility to things, susceptibility analysis, and you see the whole county, irregardless of depth to bed or depth to water, is susceptible. And that has to do with these karst features and how quickly the water moves through the subsurface in certain situations. And the problem really is we don't know when that happens or where that happens. And so can anybody tell me what this shows? So what is, but it doesn't show rocks.
It's water. It's where water is still able to.
It's filled with soil, right? So it stays moist and the grass stays green. And yeah, so it's this crack filled with a bunch of soil. So it stays moist and yeah, exactly. So it's kind of an interesting picture. And this is what, a lot of places look like. I always joke. So on our property, we've got a bunch of these and I always wonder what would happen if I just dumped some dye down there and like where it would come out. But I don't know. Anyway, I don't worry, I'm not doing that. I have to be careful. I'm recording this. But anyway, so if you look at this is on the side of the highway, just south of Sturgeon Bay. And so it gives you it's hard to see with the lights and things in here right now, but it just kind of illustrates those vertical and horizontal sort of movement pathways for water. And if we look at typical infiltration and water and how it moves in the subsurface, we've got our surface soil, we have water, raindrop hits that and it infiltrates, vertically through the subsurface. And water kind of closer to the surface is there for a relatively short amount of time. And then, sort of as it gets deeper and deeper into the groundwater table, the residence time for that water droplet, if you will, is longer and longer. And so that's what we see a lot of places. But in Door County and places that have those karst features, it doesn't really work that way in a lot of cases. So for example, and obviously this is an exaggeration, but this is, just kind of illustrating sort of, these little sinkholes. And then we've got a lot of these crevices, both vertically and horizontally. So, for example, if you happen to be right here and something, hits the subsurface, it might go through a fissure and travel vertically very, very quickly and then, oh, whoops, it can go horizontally and then go, 2 or 3 miles very, very quickly. It doesn't have anything that slows it down. So most of the time, groundwater moves by infiltrating through the pore spaces of sand, rock, clay particles, whatever it is. And there's like a hydraulic pressure that's required to kind of move that that conductivity through the subsurface. When these are just free floating channels. I mean, they're just literally water like flowing through cracks and crevices. So water, the bottom line is water can travel great distances in in very short order, at great speed. And that's not typical. And that's what makes Door County very susceptible to particular contamination events. And one of the reasons that it's difficult to understand what water resources are doing. We try to catch the study right after groundwater recharge. And so this is where groundwater is recharged in terms of snow melt, movement of water. And so like if we look at the spring, and what that means is we have groundwater levels at a particular level, and then all of a sudden you'll see a large increase as that groundwater is recharged. So we're adding a large amount of groundwater to the subsurface. And so this was the spring of 2024, and the arrow represents where that sampling event was. And we don't know this ahead of time. There's no like farmer's almanac of groundwater recharge. So we just try to pick it. This year, I think, or these last 2 years, I think we got really lucky in both springtime, unlucky or lucky. So because the groundwater recharge can do two things. So it's great to know when it is relative to your sampling. But it also provides a lot of extra water to the subsurface. So it changes and moves things at the same time. So just after recharge there, and then here, just maybe a week or two after recharge. We've had a couple years where it's been a little bit before, but one never really knows. But we do like to keep track of that because the testing, one of the unique things about this, there's a couple unique things about this program, but the first unique thing is that the water is collected by all of you, and thank you for that. Well, I think all of you participated. I don't know why you'd be here, but it's at really the same point in time. So we don't have samples. We get a lot of calls about, oh, I couldn't be there, or this, that, and the other thing. Can I still submit samples for the study? We're happy to help you analyze your samples, but we can't include them in the study because we want them done at the exact same time. So we're comparing apples to apples and oranges to oranges, right? So there's a lot of groundwater data that gets collected over the course of, a year, this year or next year. But we don't always, we can't always compare meteorological conditions and other things year to year and even within the same year because things change. So we do it within a 24-hour period in the spring and 24-hour period in the fall. And in fact, it's probably a little bit less than the 24-hour period, but it depends on when everybody collects their samples and all that. So what are the things that we look at? We're looking at standard testing parameters. So if you have a public water system, and in Door County, if you have a tourist rooming house license, so you're an Airbnb or rent out, whatever, or if you're a transient non-community well owner, so any business, church, bar, restaurant, snack shop. I mean, anything outside of Sister Bay and Sturgeon Bay, every business has a well, and that well then also has to be tested for bacteria. So the microorganisms, we use a coliform E. coli test. Those are the best standard we have. There's limitations to those, but that's an indicator for fecal contamination. So that's telling us it's an easy, reliable, and sort of the gold standard for looking at microbial contamination. It doesn't tell us if there's protozoans. It doesn't tell us if there's enteroviruses. It doesn't tell us if there's, certain other types of microbes that are there. But what it does tell us is there fecal contamination in the water? And it's pretty good at that for the most part. And this is the image from UW-Stevens Point. It's a little bit outdated. Jackie actually just looked. There's nothing newer. So this is private data that's been submitted. And they have Door County up in this 20 to 25% of all well samples for bacteria come back positive. And I'm gonna come back to that in just a minute because Door County is much, much less, and we've seen that go down a little bit. And I also think there's another unique thing that we do in the lab with the bacteria samples. as part of this study that hopefully we'll touch on a little bit later. Where do we come up with bacteria? We've got our usual suspects, right? We've got, leaking septic tanks, it may be agricultural runoff. It could be poor well construction or maintenance. Those are big ones. These are all things external to your home. In your home, you can have cross contamination. Nowadays on DIY, yeah, that's a DIY. Wow. DIY shows you can remodel your whole kitchen in 30 minutes. So if people want to know how to do plumbing, you can look up all sorts of things. It's not always a good situation. So those are some examples. We see poor maintenance. Yeah, that's a thing, right? And so that's why the big red arrow. Hey, Kleinine showed me a picture with a big brick on there. We can say this is what most wells look like today, right? So in Door County in particular, they're 6-inch drilled wells with the sanitary steel on the top. There's outhouses, we don't see that. I don't know. I doubt there's any non-vaulted outhouses left in the county. They are legal in some parts of Wisconsin. So anyway, we see this infiltration of microorganisms from the surface, and then usually some filtering of them out. Nitrate is the next most common parameter. So bacteria and nitrate are collected by all transient non-community wells. And in Door County, to give you an idea of the importance of this and the recognition of the transient nature of microbes in the subsurface, most transient non-community wells in the state are sampled for bacteria once a year, nitrate once a year. In Door County, bacteria 4 times a year, so quarterly if you're open, and nitrate once. And that's a recognition that there is a lot of variability in those results. And that is unusual. Wisconsin has more transient non-community wells than any other state in the country. It's a tremendous amount. I'm not really sure why that is. Vilas County, what is it, 450 in Vilas County alone. Here, there's even more than that. And then if you looked at, I asked for all the transient non-community wells for like 20 years. It was something like 120,000 lines from in Excel of just Door County data, because that's all public information. So that's all on the DNR website, and people can look that up. So it's a tremendous amount of bacteria sampling. Nitrate is a chemical indicator. Nitrate or nitrogen in the environment is 100% mediated by bacteria. And so when we do nitrogen fixation during agricultural, certain crops, leguminous crops, or we're doing denitrification in wastewater or in the environment, those are all microbially mediated steps. And so it also is an indicator, a chemical indicator of, other things that might be present in the environment. So sewage, septic, animal waste, agricultural runoff, fertilizers. We've had a number of cases where we've had, not in Door County, but other places where golf courses might get a little aggressive in their fertilization, or they fertilize and then it rains or something. And so there's a variety of sources for nitrate, but the one place you don't really find nitrate contamination, and the key difference between nitrate and arsenic and bacteria is it's really difficult for you to contaminate your own well in your house. So this is something that's coming out from the outside to your water supply, and then into your house through your well. Again, this is the same Stevens Point data, a little bit older. The MCL, as you'll see in a minute, or maximum contaminant level for arsenic or for nitrate, is 10 parts per million. And so here's Door County up here, about 2 parts per million. So well below the MCL. And that's pretty consistent with the data that we have as well. Arsenic is the last one. And so this is pretty much naturally occurring. I'm not aware of any particular cases where arsenic contamination in drinking water locally has been from some anthropogenic source. But typically it's from a geologic source, like down in the Fox Valley, from west of Green Bay down to west of Lake Winnebago. There's a certain geologic formation there that has a tremendous amount of arsenic in it. And as they kept putting extra wells and dropping the water table, it oxidized the arsenic. And so they have special well casing requirements and everything. So in Door County, again, the MCL for arsenic is 10 parts per billion, so not parts per million. And so we see in Door County that the numbers are pretty low, which correspond to what we find with most of the results here. So if you got a report back What does it mean? Again, just to kind of put this in perspective, when we talk about parts per billion or parts per million, we're talking a couple drops or 3 drops in a barrel, 42-gallon barrel. Parts per billion is, again, 1 drop in a tanker truck, just to put this in perspective. And now we have other contaminants, like if you follow water, emerging contaminants in water, like PFAS, and that's at parts per trillion. So we're talking 10 drops in the entire Rose Bowl. So extremely small amounts of these things. And so, and these parts per billion, parts per million, parts per billion, parts per trillion translate to, milligrams per liter, micrograms per liter, nanograms per liter. So they're very small amounts, but each of these is a little bit different scale. So when we report those results, it is important to pay attention to the units. So the total coliform MCL is 0. And the same for E. coli. MPN or CFU, if you might see that, that's an older term. Older tests used to do classic microbiology where they'd filter it and you'd count the colonies, and it would be CFU per mil, per 100 mils. And that's unique too. So you notice all these are milligrams per liter. Bacterial water quality is per 100 mils. That's an artifact of methodology for years. Newer methods, I think probably 99% of all the labs use a method that produces an MPN, or most probable number. So it's based on statistics. This brings me to the point of one of the unique things of this study. If you go and grab your water sample in your bottle and you send it off to the state lab, or you bring it into somebody else's lab, even if you bring it into our lab here, they're going to take that bottle, they're going to put some reagent in there, and they're going to give you a positive or negative. And since the MCL is 0, if there's anything in that and it turns it positive, you'll get a positive result. And so they'll say, oh, your test is positive for coliforms or positive for E. coli. A unique feature of this study, and most labs will be able to do this for you, is that we quantitate every sample. So when we do that, it provides us a lot more information. It's a little extra work for the lab, but what it gives you is a number somewhere between 0 and, well, hopefully you don't get up to 2,419, but it gives you a range in there. And so why that's important is I don't think most of you are trained samplers, and things change. And so what it does is it gives us an idea, are the positives. You have coliforms on your body right now. And so you could accidentally contaminate it. A lot of drinking water faucets and valves and things in your house will have little biofilms on it that have relatively harmless coliforms on it, and they might, have 1 or 2 that would turn your well positive. Sometimes people don't want to crawl down in their basement or their crawl space, so they go out to the outdoor tap, which is a frost-free faucet, which is not advisable, but they do it because it's easy. And it helps us distinguish between whether it's potentially a sampling artifact or issue or something to do with the drinking water system internally, or is it really coming from the drinking water, more of a concern. In the case of nitrate, as I mentioned, 10 parts per million or milligrams per liter, arsenic 10 micrograms per liter. And so if it's over that, it's considered, unsafe. Yeah. So, oh.
Sometimes instead of saying 0, say not detecting.
Yeah, good question. So if you say 0, that means there's nothing in there. Most analytical labs will say non-detect, especially for like chemical analytes, because there's a limit of quantitation. And so if you're below that, you can't say there's nothing in there, but it's not detected at the level. So all the instruments are certified for the Safe Drinking Water Act within certain levels. So if you go below that, you can't say it's 0. And on the MPN table for the bacterial method, there's never a 0 on there. The lowest is actually just says less than 1. So that's why they put ND on there instead of 0. Some labs do put 0, but it's really not technically correct.
So what is the experimental protocol that you use to quantitate the bacteria results?
So the question is, what's the method? So we use a IDEX ColAlert method. So it's what's called a defined substrate test. And so it does the coliform and E. coli at the same time. So essentially we take your 100 ml bottle, we add a reagent that has 2 fluorochromes in it. Every coliform has beta-galactosidase in it for lactose metabolism. So when a coliform encounters that, it actually cleaves off a yellow sort of pigment. And then if there's E. coli present, they have an enzyme called beta-glucuronidase, and there's a fluorescent enzyme that's released when that is cleaved. So when that's put into the bottle, then that bottle is then put into a tray that separates that 100 mils into 49 1.86 mil. This is like, there's like a 6-page statistics of this if you're really into it. And then it of 1.86 mils, and then 48 wells of 0.186 mils. And then depending on the numbers and how many of those are positive, there is a standard chart for that. And it's like playing Battleship. You look at how many positive and how many. And back in the day, this is dating myself, people would put test tubes and you count how many positive and negatives. And there was actually, sort of like almost a slide rule table that you would use to calculate the same thing. So it's a much more efficient way to do it. No, this is still manual. So the IDEX doesn't have a automatic reader. We actually, the lab here, we're doing a study this summer. They have a new instrument called a Tecta. So we were the first ones in the state to be certified with this. It actually does it all automatically for you. And that's certified for drinking water, but not for quantity. So for presence absence, but not quantitation. So the bacteria samples for this study are done exactly the same way the beach samples are done in the county. But what we're now doing is comparing our quantitative beach study with the Tecta numbers, because the instrument determines it, but it's not approved by EPA for that part of the test. So we're hoping we'll be able to use that data to get it approved, but that's the only automated way to do it. So yeah, good question. Anybody else? You got me all fired up. That's new. Like every time I do this, somebody's got something new. Gotcha. Anyway, so yeah, and non-detect, we just talked about that. Arsenic is the same deal. It'll say non-detect if it's below that method quantitation limit. We also get back a cumulative result that'll have, I'm not really sure what the history of why we call it cumulative, but it's also giving you some other, sort of physical and chemical measurements of your water. So pH, iron content, I think if you have a lot of iron, you kind of know it, right? But anyway, it's kind of a screen for that, some hardness, and then alkalinity. So these are just sort of standard tests. You can call the Culligan man or whoever. I'm not advertising for them, but like they always come and test your water and tell you need a bunch of equipment. So anyway, it's all that same sort of test. So, you're all here to find out what the results were for the spring, and you don't have to listen to me tell you that, because Jackie's going to tell you that.
Don't get too excited again. Okay, so going to be all the results that we had for our spring 2025, which happened in April. So we'll first look at the coliform bacteria throughout the county. We had pretty low levels, which is good. We didn't have any that were greater than 100. We had 2 that were between that 10 and 100. And then we had 13 samples that were between that 1 and 10 level, which Greg kind of mentioned. We associate those more with sampling air, potentially not sterilizing the faucet well enough, or using a tap that's not the best to use for those samples.
So the question that I have for that is, if you look at the one down in Southern Doors, the one that's the most orange, then you have the green one, yeah, and then the green one right above. What's the distance between those two? Do you know? In other words, is it all coming from the same aquifer? Or do you think it's a sampling area?
Yeah, so for the people online, the question is, if there's an orange dot next to a green dot, do we know the distance from them? Are they drawing from the same aquifer, right?
Right.
And so the short answer is, we know the distance because they're all geolocated. Sure. We didn't just guess where the ball's going here. But the second part of that is more difficult because we try to collect well depth and all of that. And so we don't know how far the end of, if one's 1,000-foot well and one's 100-foot well, there's, significant difference between those. The thing that makes comparisons like that really difficult with just individual spots is all of that fracturing.
Yeah.
So water can just bypass, one area. And if you just happen to be unlucky and your well's, drawing from one of those crevices that's coming from somewhere else.
Right.
So it's difficult to say who shares water. we're gonna talk about a septic tracer thing a little bit later and maybe, but yeah, so we have collected some well depth. The problem is a lot of, people don't know that.
Yeah.
And we've started to dig that up. We've started to look, as we'll talk about, some nitrates by area. But the bacteria is, it's a little bit difficult, because we don't have a lot of information.
Right, and I know you ask for the well depth all the time, and I know that you can look up most of that data from the DNR.
If they have the unique well number.
That's right, if you have the well number.
Yeah.
That's exactly right. So I'm just curious because that's fairly unique, those two data points right there, the orange and the green. And I mean, you have a few yellows and some of those might be farther away, but the ones that are almost on top of one another.
You're talking about these ones.
Intrigued, I'm talking about those.
Yeah,
I'm intrigued by that.
yeah, there's several. So if you want, I mean, we can get you all the other information. You'll see another graph in a
That's
minute.
fine.
Go ahead.
Square is a section.
Well, how
right?
Yeah.
far?
So it's over a mile, about a mile.
Yeah.
Yeah, so if you go a couple of these ahead, well, oh, there we go.
Like this?
No,
Like
back,
this one?
like there. So you can see the one on the right where you just saw that.
Yeah,
Now, you can look over to 2023 and you see the red dot.
yeah,
Now, I don't know if that's the same. I mean, we do know, but I don't know, like, I can't tell you today that it is. But if you'll look at some of these, like you'll see it way over in 2021, there's some up there. One of the things we were just talking about is how many of the same people resample, or is that a neighbor's house, or is it, because it's all anonymized. And so, but that's something we want to know, because when we're looking at trends and if the same people are participating, that's really useful information, because we're getting it, again, more of the apples and apples.
right.
But I think in some cases, at least with the nitrate, I think people don't like what they get. So then they don't they don't do that particular parameter, but anyway, sorry.
Well,
No, you're good.
You've been doing this
Hey,
for big years, I think.
hey, Gregory.
So this is quite good data.
We've got a question online.
Oh,
Go ahead, you can
Yeah,
ask the
hey.
question.
Yeah, can you hear me, Gregory?
yep.
Okay, super. So, one thing that's kind of interesting is, with that coliform, in my case, it seemed to have to do with my hot water heater, right? And where I was sampling. So I knew that my anode rod had been deteriorated quite a bit, and that typically happens. And then I definitely get the coliform, kind of the black water when you start running the water. And so I wasn't surprised that it was detected. It kind of brings up the question of why aren't we testing for coliform? It doesn't seem like you're requesting that the sample be taken at the pressure tank.
Yeah,
I've been taking the samples from my laundry sink, which is obviously past the hot water heater, right?
yep,
And
correct.
so that's how I know my hot water heater's bad. And I need to, that I need to stun the system. But yeah, is there, shouldn't you be asking for that sample to come from the pressure tank to
Yeah,
know
so
really
I'm
what's
just gonna
happening in the
repeat your
ground?
question. So yeah, that's a good question. So the question is, he's collecting it from the distribution system. Like we mentioned, had an issue with this hot water heater. And so as the anode rod deteriorates, which is its sacrificial job, he gets a periodic positive sample. And the question is, shouldn't we be sampling, or why do we sample in the distribution system for bacteria and not at the pressure tank? And so the answer is simply, the standard for well monitoring is bacteria is always sampled in the distribution system, because there's a number of ways to introduce bacteria in the distribution
Yeah.
system that
Oh,
is
yes,
not.
there are.
Yeah, so for example, like you're talking about a hot water heater, but people will also put in those whole house filters. They'll put even an old RO filter, water softener. There's a lot of things that people can open and access in your building, and introduce bacteria and fecal coliforms into your water. I've even seen somebody that connected their water system to an old dry well, because he heard dry well and thought that meant, like, if the city water went out, then he would be able to turn his well water on, and it turned a whole section of the city's water distribution positive. So the simple answer is, that's the standard, because you want to test the fecal coliforms and the microbial pathogens where you're drinking it. In terms of the and if you get positives in your distribution system, then you go back to the sample tap right away to determine, is that positive result something coming from your distribution system, or is it coming from your well water and your what we call raw water or source water itself. In the case of arsenic and nitrate, there's really not any, I think, reasonable way that somebody would contaminate their distribution system with that. One of the most common things we see are the little O-rings and seals and things in old faucets, or if you have a faucet that giggles. Coliforms are ubiquitous and they're transient in water systems. The thing you want them to do is kind of move in and move out. And you start getting biofilms that form and other things. And so what that'll do is allow more pathogenic things, particularly Legionella and underused homes. They'll actually partition onto those biofilms in your distribution system. And then that's where you run into health risks. So that's my long-winded, maybe I should be a politician. My long-winded answer, but I actually answered the question.
Well, yeah, you pretty much did. I mean, I think the issue I had, the issue is that, whoever was asking the questions in the room there, right, is wondering, how far away is that orange dot from the others? I mean, if the sample actually was from the well at the pressure tank, then the question is, in my opinion, kind of relevant, right? Because that means that the drinking water source is the problem. If it was from a what did you call it? A distribution system issue, then, it's kind of a different issue, different concern area, I guess. It's a concern for the home, not a concern for all of us on this call, kind of a thing, right?
Correct. Yeah. So, and that's the reason we quantify. Okay. I think generally speaking, if the numbers are like 1, 2, they're very small numbers. Those are consistent with things related to the house and the distribution system and the water system at the home. If it's really in the source water, that's where we start seeing the numbers up above 100 and like these red dots or even the orange dots. And that would be
really? Okay.
Yeah. So those would be. I mean, if you're certainly over 100. Again, there's no magic number for this, but my opinion would be like over 100. That's probably something entering your well for some reason.
Okay.
And it could be a natural reason, but the 1s and 2s and 4s, those are likely things related to your distribution system. It's not it's not a bad thing to disinfect your well system once in a while. I mean, it's just the shock chlorination is easy. It's good maintenance. We had one facility that had operated for 65 years with no problems. And then suddenly it had nothing but positive bacteria samples. And we actually had to treat it with acid and chlorine to get enough chlorine content. And we think what happened is over the winter with poor use, a biofilm formed and it just happened to, get a little bit out of control. So it's not a bad thing to do to a system. And like in your case, you're opening up your water heater and you're putting new rods in and so then you're having the potential to introduce things into the system at that time.
Right. Okay. All right. Awesome. Thank you very much. Sorry, I extended the meeting probably.
No. Everybody's sleeping here, but I'm just kidding.
Oh, okay. Good.
Okay. I think we finished this one. So E. coli, we had a pretty good season. We only had one positive E. coli sample and it was up in Washington Island, so way up there. And it was a pretty low level. It only had 1 NPN of E. coli, so it didn't have a large amount of E. coli, but still concerning. But then everyone else had no E. coli, so that's great.
So, I'm sorry, Jackie, just a quick question then. So is that similar to like the coliforms that at that level you would expect it's a distribution kind of system error or a water source problem?
Yeah, sorry, could I just?
Yeah, go ahead.
Yeah, so no, if it's so the question is that the same situation as a coliform? And the answer is no. So an E. coli positive is not considered something that you would typically get from your distribution system. So that's probably from source water. E. coli is more short-lived in the environment. So it means more recent fecal contamination has occurred. And typically,
Okay,
I mean, I'd have to be pretty graphic to describe how you might get E. coli in your distribution system. That's not something that we would typically see like a coliform.
okay. Okay, all right, interesting, thanks.
Okay, for nitrates, so we had 2 that were considered unsafe to drink. Those are the red dots here, so we've got 1 here and 1 here. We had 12 that were between the 5 and 10, so those are going to be the orange dots on the map. And then we had 34 that were between 2 and 5 milligrams per liter, which are all of the yellow dots. Which you'll see when we go a little bit further, but we typically always see a lot of yellow ones around this Bayshore Drive area. And when we get to our county-wide average, we'll kind of compare those to without Bayshore Drive and with Bayshore Drive. And then 166 were less than 2, so those are all of the green dots on the map. For arsenic, we had no unsafe levels of arsenic, which is great. We had 6 that were between 5 and 10 parts per billion, which are your orange dots, 14 that were between 2 and 5 parts per billion, which are your yellows, and then 151 that were less than 2. There are a nice little chunk over here. You said, I don't remember what road you said that is over there.
Oh, that's over by Clark Lake.
Okay.
Clark Lake is-
The shoreline.
Yeah, that, it's on the
Yeah.
east side of.
Yeah.
So yeah, arsenic was pretty good, which is a good thing.
Yeah.
So we kind of looked at this map already, but this shows all of the maps of spring from 2021 to 2025. Unfortunately, I can't fit 2020 or 2019 all the way to 2025 on one page, but this kind of gives you an overview of the years of our spring events for coliform bacteria. We had, again, a pretty good year. There are some reds in the other ones, so that's great to see. And then here's them all numbered out for you to see. So we had those 1 to 10 are the ones that we are assuming are potentially sampling errors, which on most of the years, that's where the majority of the percent is. And typically what we recommend at the lab, if you are getting that level that's between 1 and 10, we recommend that you do resample, make sure you're properly sterilizing, check a different faucet. Maybe that faucet isn't the best to sterilize at, or you can go directly to your pressure tank tap to see if it is your well.
Don't we normally test that at the pressure tank?
For bacteria, we recommend a test within the distribution system, but your nitrate and arsenic is usually at the pressure tank. Yeah, yep. But like we kind of mentioned before, if it's maybe your water heater, your well could be testing negative for bacteria, but your laundry sink is testing positive. So you can kind of go back and see if it's a well source or if it's something in your house that's causing that positive. And then this is just a comparison of spring of 2024 and spring of 2025. So 2024 is on the left and 2025 is on the right. And we had these past 2 springs haven't had any large amounts of coliform bacteria. E. coli. So here's E. coli from 2021 to 2025 of spring. It doesn't look like we had any above or any red dots. And usually E. coli is pretty good. We have a few that were in that orange range, so 10 to 100, but usually E. coli is pretty low.
But the only consistent one is up in Washington Island.
Yeah, and
Yep.
he knows. Like, it's just I think it's an older well.
Yeah, no, I'm
It's
just
just
curious
been-
because that's the only thing that's consistent with all that
Yeah.
other data.
Question about, as we're looking at the trend data, things seem better. Gee, aren't we doing a great job? But with the rising and falling of the lake level and the fractured limestone, is there like negative pressure that's pushing that when the lake was 5 feet higher, that was pushing stuff back in? Or? do we
I don't know if you know that, I wouldn't think so, I don't have it as part of this presentation, we were just here last week and I had one that showed groundwater elevation, it's higher in the middle of the county. And so the hydraulic conductivity of the groundwater goes from the middle of middle of the peninsula to the shores. So as the lake levels, I mean, there may have been a little bit more surface water, groundwater interaction right at the edges.
Right.
But typically, if you walk along the beaches and things, you'll see the pressure released from the groundwater through like upwellings. You can actually see sand in some cases just kind of bubbling up.
Right,
But I don't know of any cases where it's like, kind of moved backward inland.
That's my knowledge. We do have some emerging contaminant studies that we did some microplastic studies on that we use the wells on the interior part of the county, just to avoid that possibility of that. But for the most part, like Greg said, it's center of the county flowing out, but we do have groundwater contours on our web map. And if you have a local question, we can kind of say, well, this is likely where it's coming from if you have an issue.
So you actually have contour maps.
But they vary. I mean, they're
Yeah.
not exactly, 620 feet. They could vary, 40 feet during the year. But
Because
what it
now-
does is it gives us an idea of which way, if water's hitting here on the landscape, it's hitting this way, down the gradient.
So to answer her question, what experiment would you do to see if water? How could you definitively determine that there's no water coming from the lake coming in?
well, I mean, we saw water coming from in Southern Door and around Little Sturgeon or whatever. The homes were flooded, not from the lake water rising, but from the fact that it had gone into the marshes. And they were all
Oh.
flooded from behind.
When the water was really high. a few years
Exactly.
ago. Yeah.
So like in 2020, for instance, when the
2020,
water
2021
the
even.
water was virtually right on our doorstep.
Yeah.
Flowing back from.
But it's not gonna flow backwards.
No.
Groundwater up in the interior,
Right.
so it's.
In that case, it's like cover, I mean, it would be really part of a contiguous water resource, right? So the groundwater is coming down. So the question for the people online is about surface water and groundwater interaction. And when the lake levels are very high, is there movement of lake water into more to the interior of the county? To cause other parts of issues. So as the water's moving, as the lake levels go up, likely, I don't know this, I'd have to look this up, but the groundwater levels will move up so concurrently with that. And so it just provides more conductivity, in the center of the county, but it's gonna kind of flow, as Greg said, until it hits that water level. Now, if the lake water is over the shoreline and is flooding your yard, now it hits it at that point, right? I mean, that's just, and it's saturated from there down. So from that point, there would be a connection, but it's not really truly that the lake water is moving in the subsurface.
It's like a traffic jam.
Yeah,
It's a discharge area. The lake is a discharge area.
right, it's just
You're dealing
moved.
with head, so at the middle of the county, the head's up here, at the lake, the head's right here, right?
Well, this is the most engaged group we've had ever, like, I'm hearing like, engineering terms and,
Still away.
yeah. So I don't know if that answers your question, but when there is flooding from the surface, that's a really big concern for well contamination for a number of other reasons, right? So along the sides, when they drill your well, I'm a licensed well pump installer and septic inspector also, so we do a lot of these other things, but when they drill the well, the annular space of the well where it's drilled and the size of the casing, there's a space there, that's supposed to be grouted and there's ways to seal that, over time and, depending on the quality of that, and the well casing is supposed to be 12 inches, above the grade. They're not always, right, the landscape and like you see them buried in somebody's flower pot or whatever. But when the surface water comes up and you can get a short circuit either down the well itself or in that, improperly filled annular space, then that's a short circuit right down to where your well pump is actually drawing it in. So that's really, when you have flooding, those are the biggest concerns for well contamination, not nearly as much as sort of the infiltration from that flooded water going through. If that makes sense.
So here's the E. coli numbers since 2019, so our first season, and then we started doing it multiple times a year in 2022. So 0% this year. We had 2 samples last year that had E. coli levels. And then this is just a comparison from last spring to this spring for E. coli levels. And we've got that one up in Washington Island, and then there's one orange over here, but well, we'd have to look if they participated again this year, but looking at nitrate, here's nitrate from 2021 to 2025. We'll kind of go into this more in depth in a few slides here where we look at countywide data. We typically always see high levels over in the Bayshore Drive area. And then we had 2 unsafe levels, so greater than 10 this year. There was one in Southern Door and another one in a little above Sturgeon Bay. One was at 10.5, so just above that unsafe level, and the other was around 12. I don't know which one's which. And then here's the numbers, so from 2019 to 2025, and anything that's greater than that 3 milligrams per liter is indicative of contamination in the well. So we had this season, so spring of 2025, there were 6% that were between that 5 to 10 part per million range, and then 1% were 10 or above. And then here's the comparison from last spring to this spring. Last spring, it didn't look like we had any that were unsafe, and we had 2 this spring. Looking at arsenic, here's arsenic from 2021 to 2025. This year, we didn't have any that were above that 10 level. It looks like in 2023, we had 1, and there were 2 in 2021. And then we generally have pretty low arsenic levels throughout what we've all seen. It looks like the last time we had one that was above the safe limit was in 2023. And then here's last spring and this spring for arsenic. And then this is just kind of our countywide percentages. So this spring we had 7% that exceeded the safe level of coliform in their drinking water, less than 1 with E. coli, less than 1 with nitrate, and 0 with arsenic. So looking back in the season, it looks like the lowest year would have been spring of 2024. But we're still on that lower range, with the highest being in fall of 2021 for coliform.
So one of the things that we wanted, now that we've collected a lot of data, is to start looking a little bit more in depth and sort of segregating out sections of the county. One thing that I'll note is that when you have microbes get into the drinking water, everything's different, whether it's protozoans, bacteria, viruses. Generally speaking, in the case of the bacterial indicators, they survive on the order of days. So E. coli, very short-lived. Coliforms, maybe a week or a little bit more, depends on the conditions, but not very long. They're relatively short-lived in that type of environment. Things like nitrate will persist for weeks, months, even years. And in many places, you'll actually see that build up in the groundwater. And so one of the things we want to, and we've had cases where it's very predictable. You're business ABC and you're sampling your well, and one year it's 5, and the next year it's 5.5, and then it's 6, and then it's 6.5. Well, you don't have to be a rocket scientist to figure out when you're going to go over the 10, right? And so we wanted to start looking at that one now that we have a little bit more data. And there's certainly, like, if we had unlimited time, we could go a lot more with this, but we just started this a couple years ago. And we wanted to look countywide at nitrate numbers. And so this is looking at the mean for the county of nitrate concentration. So this is in our parts per million. Good year here. One thing to keep in mind here, the scale is really small. So it's really compact. So we're talking 1.7, 1.06. But really, if you a pretty consistent level and it's slightly downward trend, over the time from fall of 19 to the spring of 25, but all just a little bit over 1. That looks pretty good, right? Because the MCL is 10. So things look pretty good. Certainly not moving in a negative direction. But now, as we realize from those pictures, not all sections of the county, have green balls all over them. Some of them have, yellow and red or whatever. So we separated the county out into zones. 1 starting at the island and 5 in Southern Door. And there's no sort of, I'd love to tell you like there's some real statistical algorithm that we used to do this. But we just followed the highway and like we just made it. I mean, we had to pick arbitrary. We didn't want to preconceive like, oh, let's get this red one in this zone and this one and that one. So we followed major roads and different things. And so we just separated it into these 5 zones, and we did separate the area, most of what's Sevastopol here, north of Sturgeon Bay, into A and B, because we recognized that there were some differences happening on the lakeshore and then on the bay side. So anyway, so what we did is zone 1, this is out on the island. It looks like, I always joke, this looks like somebody guessing on a multiple choice exam. They're doing the sawtooth as they go through here. But I mean, really, really low numbers, right? I mean, there's nothing there, relatively low numbers, again, Washington Island. And then we've got zone 2. So this is this, section just below, the tip of the peninsula. Again, more, it looks very variable, but it's really not all that much because we're talking 1, these are a little bit lower, but and I guess you see sort of a trend, but the correlation would be very, very weak there. So it really doesn't mean much. Here's zone 3. So, I mean, I think remarkably consistent, pretty low, right? Yeah, looking good. Well, that one's a little different. So this is the Bayshore Drive side, so the west side. And I don't mean to pick on people from Bayshore Drive, but that's just the main road that have a lot of participants. And so you see the numbers here much higher, but still relatively low, right? So we've got 3s instead of, if I go back, I'll show you a summary in a second. So we see 3s to 4. This spring actually we just put this in. That's 2. So it came down again. And if we map it out, we've got, the whole of zone 4 in the blue line, zone 4 without Bayshore Drive, and then we've got Bayshore Drive in the red, which shows consistently till this semester, I was gonna say semester, but this sampling event, it shows, it goes below the average, but typically the participants on Bayshore Drive show a little bit higher level. On the other side of this is like, again, up, down, up, down, and up, down. And so you do notice it is kind of interesting. At first I thought, well, maybe it's a spring. Well, okay, here's the fall. Oh wait, here's the fall. So there isn't any really clear pattern. We do see a few years where it'll go up and down. Where this might correlate, and we haven't really looked. Remember that recharge that we talked about? We have not went back because we know we can go back and do this, but we know that we've hit the recharge. We've sampled after recharge in some years, and we've sampled before in other years. And so, I don't know if you've heard the old adage, right? The solution to pollution is dilution. I mean, it's not untrue as it relates to nitrates. So when you add a large volume of water, it disperses a lot of that nitrate material that might be hanging out in a little bit. And so there's a variety of interactions that may occur, and that may be what's going on here. We don't know. It could be as simple as different participants also. So we haven't went back and looked at that. We just, from talking to people, we know there's a pretty good group that's like, it's kind of like our well testing groupies. They come by every year. I always sit at the ADRC and the same people seem to drive by. And that's great. But we also know there's new people. Like every year we have people like, I didn't know you were doing this, and so anyway, so we're not sure what that effect is, but we were hoping to look into that a little bit more. Southern Door, again, I think this surprised everybody. So a lot of people, thought that because of the amount of agriculture and other things that go on, that these numbers would be much higher. But actually they've been pretty low. So lower than north of Sturgeon Bay. Again, but this depends on participant and who's, where they all are and everything else. And if you look at it as a whole, here's all the averages. And this, I should say for everybody, that this presentation and the recording will all be on the Soil and Water website. And then you also email this out to all the participants. And so we'll get you a link. So if you want to if you don't get enough of me today, you can replay this all the time. My wife does that all the time. Anyway, but, so yeah, so you can take a look at it and that's just in tabular form. And this is a sort of graphical representation of, all of those averages we just saw. So again, 4A, excuse me, leading the way here. That 4B, so that zone sort of just north of Sturgeon Bay, typically the highest. But the good news is we're not seeing that building of nitrate in the subsurface. And so that rapid movement of groundwater might actually be doing some benefit as it relates to nitrate in the groundwater. This is our zone comparison, all seasons. So 1.1 here, 0.25 out on the island. So this is, this is, I think, pretty good data. Even if you're in zone 4A, you're not, there are individual pockets of things to be concerned with. But generally speaking, I think a lot of good information and people should be happy with that.
Concern should be consistently between 5 to 10 on nitrates.
Yeah, so the question is, how concerned should you be if your results are between 5 and 10? I guess everybody has their own level of comfort with that. So if your results are 5 to 10 and they're going up and down, up and down, up and down, it's not like 5 1 year, 6, 7, 8, there's not that trend. There's probably a continued source into that groundwater, but it's not a significant one. And whether you're comfortable with that or not, if there are ways you can remove that level of nitrate, from your drinking water in your home. Water softeners will remove a few parts per million of nitrates. Reverse osmosis works really well. Okay. Yep. Yeah. So your results then the 5 to 10 before the softener?
Yes.
Yeah, so what we tell people to do, in my home, I have an RO that we use it for drinking water and goes to the ice maker on the refrigerator. We also have water softener and iron treatment and some NASA system. No, I'm just kidding. But in that case, what we recommend if people are concerned, if your raw water has, 5 or 6, if you test the RO, it's probably 0. But you can also test before your RO or after, something that doesn't go through the RO and after your softener. If you're at 5, I would bet you're down to 1 or 2. After the softener. It depends on which technology it is and, the maintenance of it and everything. But yeah, usually 3, we've seen other places 3 to 4 parts per million it'll remove. The RO should take it all out. RO is for the dollar spent, the cost benefit is really the best solution for not only the things we're talking about, and now we're going to talk about septic tracers, but emerging contaminants like Greg was mentioning. We talk about PFAS and microplastics, and we don't know what we don't know, right? Like what's in our groundwater. We test for things that are indicators of other things, but there are literally thousands of things that we could test for. But that's not practical or reasonable or whatever. So anyway, so one of the things that we wanted to do is start looking at maybe some more advanced techniques to determine, is there a connection between septic and drinking water? So just because we don't have our coliform test become positive or elevated nitrates to the point we have an MCL, it doesn't mean we don't have some sort of interaction between septage and our drinking water. The only way to get to that question is to look at things that are human only sorts of compounds. So anthropogenically inserted compounds. So the overall objective of the project was to evaluate septic system tracers to determine if there is this interaction in places where for the purposes of the study, we started out with areas that had higher nitrate levels. So again, back to zone 4A and 4B, right? So that's where we started. And we're going to pick a couple locations. This literally just started that are defined by, both seasonal, because we recognize, what's the year-round population of the county? Yeah, about 30,000 people. How many visitors come to the county every year?
2 million
Yeah, 2.5 last year, right? So I mean, that's like, can you imagine like how many toilets are flushing in January versus July 4th? I mean, just try to walk through Sister Bay. I don't know how their treatment plant doesn't explode, but anyway, so we realize there's the load. No, but I don't mean it like that, but the influx of material in July, is much greater, and that includes, not only municipal systems, which in the county again is unique, is that there are a number of municipal systems, but the municipalities don't have municipal drinking water. Bailey's Harbor, Egg, all of those, so they have municipal wastewater for certain areas, but they don't have municipal drinking water. So that, I mean, anyway, so there's a lot of that. So this was, we started in the fall of 2024 with just kind of this pilot study. And we looked at 10 places just to start. And I think I had a list. Oh, well, I'll show you the list of what it is. So we had this list of 10 that includes things like caffeine, artificial sweeteners, insecticide, and so things that only would come from humans. I mean, you'll be lucky or happy to know that when you ingest that artificial sweetener, largely it passes through your body unchanged. Very unsettling, right? So anyway, so that just ends up going out. But like, I mean, we don't have like fecal coliforms or E. coli. Beavers, rats, like whatever, anything warm-blooded has that in it. Nitrate, look at all those sources. Caffeine, I don't think there's any natural source of caffeine. So those are the things that we're trying to look for. So when we look back in the fall, we've got this little X's, the pink X's are where we had a positive hit for a septic tracer, and the little blue ones are negative. So you'll see a lot of them over here. So we kind of focused on this, sort of this Bayshore Drive area, and then over here, kind of along Lake Forest Park Road, and up to Clark Lake. And so we even zoomed in here in the Bayshore Drive area, and you can see a couple of these. And so interestingly, here's 2 positives. Don't worry about the stars yet. We had 1, 2, 3 positives. You'll notice those had nitrates between 2 and 5. This positive up here, the nitrate was less than 2. So in that case, there was a septic tracer found, but no nitrates. And in this case, nitrate. And then these 2 stars are actually what we found in the fall. So the 2 positives, there's 21 samples collected in the fall. Those are the 2. I've got another slide of that later. So here's our coliforms. Again, here's our positive sites, coliform negative, coliform negative. This one was coliform positive and septic positive. And so a lot of these other ones over here, septic tracer negative. This one didn't, this positive coliform didn't participate. So the moral of the story is most of the coliform negatives were negative for the tracers, but not all of the positive tracers were positive for coliforms. Does that make sense? So, and I'll show you a picture example. So there's the 2 from the fall again, kind of again where they're located. These are the septic study. So this is E. coli results again. They were all negative for E. coli. So this wasn't recent fecal material that was getting, it wasn't like somebody's Starbucks from yesterday that got in there. And so this is the list of what we were looking at. So several artificial sweeteners, some metabolites, prescription medication, and then the 3 that are included in our study. The results for the 2 that were, or the 3 that were positive, the nitrates were 4, 5, and 6.1 for the fall. And then in the spring, this is where the 2 results were. So this particular site had 1 tracer present, and this site here had 2 tracers present. And there was none, all the green dots are negative. So this is over on the Lake Forest Park Road. These were the ones on the bay side. So again, not next to each other, this well pretty close in proximity, doesn't show anything. In fact, there's one right next to this house that was negative, that also participated. And so all non-detect. 1 well had 2 things present, 1 had another one. The average nitrate for the 2, or for everybody, was 3.24 that participated. For the homes that were positive, the nitrate level was actually lower than the mean. So if I showed you out of the 21, now you guys have been participating. Normally, this is when I wake everybody up. But so there's 21 different homes or wells that were selected. These are the results for each sample. So non-detects for all microbial. Here's the nitrate, arsenic, and not all of them participated in these other things. So that's why it's blacked out. So if I asked you which of those 21 were the two that were positive for the septic tracer, which two numbers would you tell me? You don't win anything for getting this right. 3 and 13 I hear. A couple people said 13. What? Kind of hard to tell, right? Well, here's the first one, number 1. So that one had one tracer present. What do you guys, what was the thing? 13, everybody was saying? It's 18. So this goes, I mean, again, it's hard to predict things. And so why this is, we don't know, but we hope as we kind of move through the seasons and we move through this sort of, influx of material that's being, jettisoned throughout the county, we're going to be able to narrow this down. And what we're hoping to be able to identify is, again, we're not necessarily looking for a problem, but what we want to know is there something going on, or can we say there's not? Like, I think if we asked a few years ago, what is the mean nitrate level around the county? I think that would have been a difficult question to answer. And now there's a lot of information that, people that get asked that are able to answer. And so the county's got a pretty good handle. They went through and got a good handle on all, septic systems and maintenance and all these other sorts of things. So I think they know where everything is. But because, again, of that fractured subsurface in Wisconsin, there's one code. So we have one code for the state. And so states like Michigan have different codes for different parts of the state. Now, again, I'm not the smartest person in this room, I'm quite sure. But I feel like if you install a septic system out here with 6 inches of topsoil, or if you install it over by Appleton and you've got, 40 feet of clay, there should be some differences in how those are installed. There's not. I mean, they're a mound system. They might be slightly different in size, but I mean, the code is the same. So when you put those systems in, you could do everything right, everything with code, nobody's doing anything wrong. But if you're right, just for example, over one of those cracks, that's we just don't know. So, and that's where the hard part and the uncertainty comes in. Oops, sorry. Yeah. So 2 chemicals and 1 chemical present. We also have been gathering that well construction information. Just kind of looking at this, it was surprising to me. And now I found out about this. So there are wells that are 800 feet, and that's actually in Southern Door kind of over. And I didn't know that. I'm like, wow. The one that surprised me even worse was these less than 50. Like, I feel, has anybody put in a well point? I've actually done that. You can go down to the hardware store and buy like a sand point or whatever and with a sledgehammer and put them in. Like, I don't know where in the county you put that in unless it's like right next to the lake or something. But out on the island, I think there's a couple. But anyway, so it just gives you an idea. Most of the wells are, in the upper, I would say 175 to 300 feet. I mean, that's pretty typical through the county. So anyway, so what are we gonna do later? Again, as we go on, we want to continue targeting, continue this. We look at, these are, new sections. So we'd like to fill this whole map up. We'd like to go back to all this data now that we've got enough data to do things with. We'd like to, like we did with the nitrate, we'd like to do a little bit more with some of the data to your question about, well depth and where it is. So we have a lot more we could do with the data. It's just, a matter of kind of the old adage in life, right? You don't have enough time. And so what are some of the take-home messages we tell everybody? The karst geology here in the subsurface is highly vulnerable. It's highly, uneven and it's uncertain. I think that's the real term that I would use. And we recommend people sampling at least annually for bacteria nitrate because things are never a problem until they are. And it's that simple. And so, again, hopefully the data, shows people that there's nothing to be tremendously alarmed about, like the groundwater is just rampant with things. I think by and large, the water resources in the county are in very good shape and the county understands a lot more about it than they did a few years ago. But you have a lot of resources here. So, DNR staff, county soil and water staff that are here tonight, Door County Public Health. If you're interested in learning about the lab methods, getting well water tested, you can go take it to Bailey's Harbor. There's kits for places at the county courthouse. The lab here is open Memorial Day to Labor Day. So there's a variety of resources within the county to answer questions. At the end of this, my email is there. If people want to call and talk or whatever, if you have special issues going on, we're happy to try to help you out and see if we can help. We do have students that are here all summer. So they live in Bailey's Harbor. And so, if we can help you with something, we're always happy to do that. So special thanks to Crossroads. This has been my home now for 22 years, I think. And so Door County Soil and Water Conservation Department, Public Health, Community Foundation, which really started this well program quite even before the fall of 2019. They did a community-wide one as part of their water festival. And so anyway, we really appreciate that. And we couldn't do this without all of you. So this is our main information. I guess I don't have my email on there, but I'll give it to you anyway. It's super secret. But we really appreciate you all participating because we know it's just one extra thing to do. So yes, ma'am.
If we missed one of spring or fall for whatever reason, there's always a media blitz, which is wonderful. Are there other times to say, no, I mean, I understand why the study has to
Yep.
at the same time. Will there be another this fall?
There should be, yes. Yeah, we're planning on another one for the fall. And we tried putting it out. Like I said, every year we think, we all talk to ourselves, right? And then we think everybody knows what we know. But we actually put an ad in the Pulse this year, and that made a big difference. I told them, I said, wow, people actually read this thing. We know that. So if you want to participate in this study, there'll be another one in the fall. They're typically mid to late October. The ones in the spring are usually April, like second week in April, something like that. A little bit depends on schedules and things, and we just guess. You can also just test your well any other time if you want to too.
And can we, to test it, just be, if we missed one,
Yeah, you can pick up the exact same kit here. They're open here Monday, Thursday, 12 to 3. If you're here tonight, I can give you a thing to take with you, but and then you can drop it off. Same thing.
The county courthouse, soil and water and public health has test kits for a variety of places throughout the year.
Yep.
right? And part of that is when we first, 15 years ago, when we purchased our place, we went immediately because we hadn't had it tested. And it was a lab somewhere else that was like $300 and some, and it was like, oh, well, I think we can wait until the cycle comes around.
Ours is 275. No, I'm just kidding. I mean, there are the only thing I would say is there are options that are close. So like Bailey's Harbor, you can walk in and they'll do your bacteria and they'll take your nitrate. Yeah. So I would not put it in the mail. The one thing that frustrates me is when people continually send it down to the state lab. One, they don't want them. They get too many of them. But with the mail and everything, we even now have a pickup out on the island on Tuesdays. Because they were, people would come across and now Sister Bay post office won't take them. So they'd have to drive them down to Sturgeon Bay. Then it wouldn't get to the state lab in time. And then they'd have to redo it. That's a lot of effort for a $25 bacteria sample. And there are some local options that you don't have to put it in the mail. So I would just, whatever you do or wherever you go, I would, especially for the bacteria, that's what I would recommend. Yes, ma'am.
Recommend that you once in a while check your osmotic. I mean, I get it serviced. They recommend that you actually check to make sure that you don't get fecal contamination, not fecal, whatever. Some kind of a coliform or something or they're growing in there.
Your what?
In my osmotic system.
Oh, the RO system?
Yeah.
Yeah. The RO membranes have a finite lifespan to those. So depending on your water usage, in my home, I replace them every year. So some of them have a maintenance, so they'll tell you to put a small amount of disinfectant or, basically it's usually bleach, unscented type of bleach. Yeah. So anytime they open the system, they're supposed to take care of that. Some things like when you do disinfection, like water softeners, everything, they all have their own way of doing it because they have different resins and everything else. So if you're having a plumber do it, somebody should know what they're doing. They should make sure that they're not like dropping the membrane on the floor and then throwing it in there. I mean, it sounds funny, but it's people do it, and so
You guys actually recommend it once a year, because I've never tested our osmotic system.
I wouldn't be really concerned with that. I mean, you could. Yeah, I mean, I would be more concerned about the chemical, if the nitrate issue you were mentioning before. And so the one thing with RO systems, the tap, depending on the one you have on your sink, is probably plastic. I don't-
No, it's actually not.
Is it okay? As long as that's the one thing, when it curves over, a lot of them, when they curve over, it might be kind of a softer metal, but then that little end, there's a little ring on the end. And that little ring, it's kind of a decorative cover. That's usually plastic. But if it's not, you could disinfect it. But a lot of those types of faucets, the reasons we recommend laundry sinks and other things is they're metal and pretty industrial. And so you can flame them. That's kind of the standard. Sometimes people use like isopropyl alcohol and other things, but it doesn't really work as well. But yeah, I think the microbial contamination in that would, if you change them every year, it would be less of a concern. Yeah. Yes, sir.
Is it possible to drill down on any of this data to come up with an address, a home, that you might be thinking about buying or anything like that?
None of this data is, no, I mean, it's like, we don't, unless they submitted it for some public reason, it's not in any sort of database that's publicly available. No.
Because everything else you got is section.
Yeah, it's all on here, it's all sort of anonymized, so we take names and addresses and things off of all that. Yes, sir.
Answer this question, but what does all this say about the long-term sustainability of our water supply, given that we're drilling private wells in the hundreds every year? There's been talk about what consumption does to the aquifer.
Yep.
We drawing from the aquifer, or are we drawing from groundwater? What are we doing?
Yeah, so the question is, is the groundwater resource sustainable given the number of wells that are going in? What did I say last, 80,000? There's 80,000 wells, I think, in the state, and I think there's 11,000 in Door County or something like that. It's a tremendous number, and you're absolutely right. There's more and more going in. And so at some point it becomes unsustainable because you're drawing more than the water can replenish itself. And the Fox Valley of Wisconsin is a classic example of that. As the Fox Valley built, I mean, there's 1.3 million people from Green Bay to Fond du Lac. And that area west of there, as they punched all those holes in, the aquifer levels went down and down and down. Now, I don't think, I mean, Greg can correct me if I'm wrong here, but I don't think the aquifer levels, the volume of water is being impacted at this point in the county by the number of wells. Yeah. And so, but that doesn't mean it won't be in the future. And I think this is just me speaking, is that one of the things that, policymakers need to decide is, at what point, do you expand things like municipal sewer, and add water? Or because municipal sewer, just for example, municipal sewer is by far the most efficient and best way to manage waste. I mean, there's no, I'm sure somebody would debate me, but there's really not a much of a debate about that. And we do have a lot of relatively a number of municipal wastewater systems. Now, when they do that, do they put drinking water systems in, like Sister Bay, for example? I mean, and so in areas where you have large amounts of growth and numbers of homes, you can even do sort of regionalized. A lot of places in the state will have, I shouldn't say regionalized, they'll be shared wells. So as part of it, so instead of a neighborhood with 60 homes and 60 wells, they might have 20, and 3 homes may share those, and they may have a cooperative agreement. So there's a number of ways to do that, but at some point you're going to get too many, and you're going to have to manage that for a variety of ways. And the one big concern is every time you put a well in, that's a conduit directly to the groundwater. And so when you put a new one in, people need to abandon that well. They're supposed to, but it's hard to put concrete down a hole you spend $30,000 on. So they're not always abandoned properly, and they're not always tracked properly. So there's a lot to that. But I mean, if you're, whatever the number is, if you're putting 500 more a year in or 200 more a year, that's a lot. I mean, that's a significant, impact.
So, Greg, I have a question about that. His question is, how would you measure the level of the aquifer?
There are gauges in the county. I mean, I don't know where you get your hydrology data, but
Yeah,
How do you get your data, Greg?
well, on the web map, you can look under hydrography and we have groundwater contours.
Okay.
That groundwater contour map was done from a 1978 study from a John Sherrill.
Right.
So and that was like, the average water table. But we have monitored non-metallic mines over a 5-year period for the reclamation purposes. Typically 20 to 40 is a fluctuation of groundwater, 20 to 40 feet, but we've had some quarries that have fluctuated over 100 feet.
Okay.
In groundwater
Okay.
levels. But like what Greg mentioned is that, if we treat everything municipally, so your septic system, your mound system is essentially a recharge system.
Sure.
So you got water coming out of the groundwater from your well, but you're also putting it right back in your mound system, which is going right back into the aquifer.
Mhm.
So anything soluble is going back into the aquifer.
Mhm.
So part of the study is to say, are we seeing a trend that tells us we're reaching carrying capacities?
Right.
So that's what we're doing. We're being very proactive here to say, hey, something's happening, something's gotta change.
Right.
So, right now we're doing, one thing I would like to see UW Oshkosh do is back in 2015 and 16, we did a lot of well samples as well. Those nitrate levels were much higher. We use that data along with Kewaunee County and their data to get what's called the Solarian standards implemented within the state standards and our local ordinances, which prohibits manure spreading on less than 24 inches of soil
Right.
Right.
mechanically. That was a big win.
Right.
It's not perfect,
Right.
but it was what
Better.
the two sides agreed on. So, it was the Solarian standards and adopting that ordinance, the big reason for these nitrates coming down? Maybe. Is it the fact that we're down to 36 dairy farmers in the entire county? Is that the factor? You could look at the number of animals. The number of animals have not changed much. In 1945, we had 1,800 farms of cattle and calves. We're down to 36 dairy farms right now in the county.
Oh.
But again, the number of cattle is pretty much the same. So there's a lot of variables going on.
Yeah.
And the thing is the sooner we can see something happening to prevent something, the better.
Yeah, the USGS monitoring well that we get the hydrograph for the recharge is in Southern Door. It's down.
Because that's the other question I was gonna ask you was that, you notice when you look at the data I wanted to know where you get the recharge data, number one. And the difference is amazing. It's like 5 feet up to 740 feet. And that's pretty fast in what, a couple of weeks? Something like that?
Yeah, exactly. So, but again, that points to the sort of, permeability there.
Yeah.
So that's the closest to, the county. And so if you get this or send us an email, we can send you the link
Yeah.
and then you can peruse all their
I can
data.
I can go down that hole.
Yep.
So because the other question I ask is that I monitor several streams farther north. And you can tell the difference when you go out in May, how much more water there is in all the streams. I mean, it's up to here rather than down to here.
Mhm.
So that's pretty good. So I just was curious how often or where all this other recharging is.
Yeah. I mean, I don't think there's any precise data, sort of north of Sturgeon Bay. It's all, a guesstimate based on whatever we have as the
Sure.
closest.
Well, yeah,
So,
I understand.
Question was, so assuming Sturgeon Bay and all the communities here or even the cities and towns where are wells, when they have municipal water. Is that correct?
Sturgeon Bay has like 5 or 6 wells.
yeah, they're not surface water sources.
Does Green Bay use a crib and tap the lake? Or is that
Um,
ever an option or is?
oh, yeah.
Wags?
No. No, surface water. So there's a lot of municipal surface water, drinking water plants. Oshkosh, Appleton, Green Bay, Manitowoc, Milwaukee. I mean, that's, the whole cryptosporidium thing. So the reason that municipalities try to avoid that is there's a much larger cost for treatment of surface water because of what you see than groundwater. And so it's easier you think just to lay a pipe out there. But then there's a lot of other things you have to worry about and treat in it. So it's a much more costly process. So if you have the groundwater resource, they'll have, like, I don't want you to say 5 in Sturgeon Bay. Most larger municipalities will have multiple wells that feed portions of their system. That's why, like, places like Eau Claire or Rhinelander, when they started testing for PFAS, they would find certain wells would be over and they'd have to shut down, but it didn't shut down the municipal system because the other wells in their system backfed whatever that well that was shut down was feeding. But yeah, long story short is there's a lot of places that do it if you're on a large body of water. But it's not as in the case of Oshkosh, in some places, it's costly to treat the groundwater because of other problems. But if you're up on Lake Superior, up until, a decade or so ago, there were places that had minimal treatment. In Houghton, Michigan, they get it out of old mines. I mean, and it's wonderful water. So yeah, I mean, there's a lot of ways to do it, but just out in open water like that. I mean, just think about the algae and cladophora, and you mentioned mussels, and I mean, bioterrorism problems. I mean, there's so there's a lot of other considerations.
That is an option for some of the biggest areas as we get our aquifer level.
Yeah, I think if municipalities chose to get into the drinking water business, I think there's enough groundwater resource right now that they could do that way without having to install a surface water treatment plant. Yeah.
Kind of.
And I just have a little bit of an aside, and I know this is Door County, but
Nope.
from so many problems in northern Kewaunee County, have those been mitigated? Is it better? Because we're talking fractured limestone, it's not like it
Yeah.
stays in Kewaunee County.
No, I don't know.
Yeah, Kewaunee County's been doing a lot of water sampling. In general, it's getting better,
Okay,
but there's still some serious nitrate issues in some areas. The Casco area, I think they have some nitrates above 40. They're not sure if those are old nitrates, like 10, 20, 30 years old nitrates, or
okay.
what, but we are involved with a groundwater study right now, with Kewaunee and the USGS Natural History Survey, where we're logging in some wells and we're trying to figure out where water's traveling. So we've done some of that in the northern Door, but upper Kewaunee and southern Door is kind of a new water study right now, so groundwater flow. So we're working on that as well.
Reducing the seagull population, which was blamed at one point.
But
The thing is with the slurry standards, we're saying it's a win. For them, they're not quite sure yet because some of that manure is getting more concentrated on deep soils now, but they're still putting commercial on the shallow soils. So we're trying to figure out which way water's flowing down there yet.
Yeah, okay, interesting.
But if you want to look at something interesting versus surface water versus groundwater treatments, Google Iowa water bans right now. So the Des Moines, Ankeny, and Ames area, they're limiting how much water you can use right now. So you can't water your lawn right now because the reservoirs that they're getting their water out of for drinking water are so high in nitrates and other contaminants that treatment plants can't keep up with it to provide people water under 10 parts per million unless they stop irrigating the lawn because the levels are so high over there.
Say, I don't, this water is horrible.
We've got studies in our office that show some very high groundwater nitrate levels, but they also have in their surface water. They have very deep soils, which is a very deep reservoir for nitrates to build up in. So.
Kind of too bad we can't keep the nitrate in the water that waters the lawn, isn't it?
It's one way to get rid of it.
Yeah. Hey, hey, Eric, I kind of feel like, it took me an hour and a half to watch the movie or the TV show 60 Minutes, but it's a good group with a lot of good questions. I have one that maybe is, if I might, you can let me know if it's inappropriate for this to be recorded and such, but how are you funded? And then are you funded by the county or this University of Wisconsin program specifically, or?
Yeah, so our particular group, is funded on its own. So we get no state resources for, I'm just gonna exit this, for our programs. So, okay. There we go. And so that's how our group itself is funded at the university. The study that we're presenting here is funded by the county. So the county provides resources for the program to provide reduced cost sampling for participants. And then we bill the county for the number of samples that are analyzed.
Okay, so the county is interested in making sure that they're keeping track of where this is going for DOR, basically.
Oh yeah, if the county didn't support this and do this, it wouldn't happen. We started back the Community Foundation, the Healthy Waters started a large well monitoring for a couple sessions that Greg mentioned, I think in 14 or 15. And then after that, it's really been the county that's kind of led the way with it. And we're
Okay.
a partner in this with them. And we've been doing, other water work in the county, aka beaches, for a couple decades. And so this was
Okay.
a great way for us to continue to partner.
And then for the folks involved here, typically, are you just focused on Door County, or are there other counties as well that you support in the state?
We do other things. So we have a lab here. And so, we have the things that we do here are focused on Door County. We also operate a transient non-community well program for Vilas County in north central Wisconsin. And then we have done that for, I think, 6 other counties. That program's about 20 years old. And then our main lab in Oshkosh serves the Fox Valley region and is open to the public as well. We also have a lab over in Manitowoc that does beach work for that part.
Okay, super. Well, thanks so much for sharing. And I know everyone I've worked with on your team has been very patient with my questions and very helpful. I know Jackie and I have interacted on several occasions, and others as well. So thank you very much. I really appreciate what you guys are doing and what the county's doing, in fact, to show interest in this. And thank you so much.
Great. Thanks for the feedback.
Yeah.
Any other questions? All right. Well, thank you all for coming. And those of you online, like I said, the recording will be available shortly. So have a good evening.
Great. Thank you so much.
Bye-bye.
Good night.